busy in the ministry, world improvement for 19 years. We were set up 19 years ago. We have developed over 150 different technologies of different kinds. This is one of the machines we'll be demonstrating today. It puts out extra energy, enough to run itself and light up some lights. And
I thought that was impossible.
that's what we were all taught. The new paradigm shift is to realize that these things are going on all around us. Solar panels are over energy. We even have some that work at night now that are still in the experimental stage. And we've been doing nighttime solar panels for 10 years, but the rest of the world's finally talking about it. See, the stars give off energy. Everything gives off energy. Matter itself will give off energy. Even the ether field will give off energy if it's stressed correctly. The gravity field, if you want to say it that way. The gravity is one aspect of the ether field, or the dominant energy field. And that will give off energy if it's stressed correctly. So literally, a field that appears to be neutral, which they define gravity as neutral, they define magnetism as neutral as far as energy output. But if you stress them correctly, you can get them to give off energy.
Fantastic. Well, what have we got here? Here we are underneath here. Here we are underneath
Let me
here.
lift it up. Since you're looking at everything here, just take a picture underneath there.
Okay.
And just so we got it, in case somebody wants to see it, you can always cut it out
Nothing's
later.
inside.
You always, let me look underneath this one too.
And there we have again. Nothing inside. It's just an empty cinder block.
Okay, there we go.
And then we have capacitors, light bulbs, very interestingly wound motor, the motor that's turning the larger motor, and the varostat that controls the speed.
And we've got a diode bridge there with a heat sink. Over here we have some electronic components. You probably can't see them on the video, but basically helps keep it stable and controls the amount of power, so that and even gets it in the right frequency range, because this is a variable frequency generator. But over here it's 60 cycles, which is what you want, pretty close to 60 cycles.
Okay.
And it controls the voltage so that the voltage is the same, it's not going up and down and stuff like that. So similar to inverter technology right there.
Okay.
And you got a bank of capacitors, and you got the load. Basically, that's the parts. There's also components in this blue box and that blue box.
Okay.
Yeah.
So what do we do now?
Okay, so we'll start it up.
Okay.
It starts up with regular power.
Okay. So you have to plug it in to get it going.
On this model, yeah, you could use a battery.
Okay.
It could be done in different ways.
So we have an extension cord here.
Make sure everything's set right before we turn it on. Okay, we're starting it up. I see blue sparks over. I can still see them. You guys should see this. Come over. Before it blows up.
Wow.
See them down
Yeah,
here?
they're touching.
There's actually, when I touch this, it gets a lot more. See there's 3 or 4 or 5 of them?
Yeah.
In the dark? Let go and it's less. You see that?
Yeah.
Hopefully it'll last through the demo. That's because we tilted the box.
Oh, I'm sorry. Okay.
Hopefully it'll last through the demo. But that's some of that exotic energy we're looking at there. Okay. I'll turn the power levels back down. We don't need that much power.
Okay.
One other thing we're doing right here. And then we'll see if we got a light bulb lit. If we do, we'll switch it over to running itself.
Okay.
And if we get a big bang, don't don't jump out of your skin.
Okay.
If this one shorts, it usually makes a noise like
Pop.
about 10 times louder than what you heard over there.
Okay.
So maybe like a gunshot.
Okay.
Oh, you got power. Okay, now we'll unplug it. And we got it.
So it is now disconnected.
Yeah,
It's running itself.
yeah,
It is now a self-sustaining power supply.
yeah. Very good. And let me light up some lights here. Put on my shades so it don't look so bright.
And it hasn't seemed to slow down at all.
It shouldn't, because that voltage thing is a stabilizer. That should keep the voltage and the amperage completely stable.
What's the wattage on those lights?
Right now we're at, the lights were at about 900 watts.
900 watts of light bulbs, and it hasn't slowed down at all.
No, it won't slow down. That's old school stuff when you gotta slow it down.
So it's running itself and providing power.
Yeah,
So it's self-sustaining.
yeah. So basically that's it. Too bright to look at.
Can this be scaled up?
Oh yeah, we've already done over 20 million watts of power on different tests for ourselves, basically.
Now, a device like this, could it be used to run a car, or would it just be used to run a house, or a building, or a factory, or what would
Already
you
run
do?
cars, already run houses.
So this is old to you.
Yep.
Now, as it's running, can you explain a little bit how this power could be self-sustaining? Is it from that big box of capacitors you have down there?
The capacitors help establish the resonance. Those are AC capacitors. The energy, they go to zero about 100 times a second. They're going to zero. So they're charging and discharging to make an oscillation, a resonant type oscillation.
So it wouldn't be possible for those capacitors to hold the storage charge you'd need to keep that motor running.
Those capacitors, best case scenario, you can get the lights to light up for maybe 10 seconds. Best case scenario.
So the secret isn't in that little starter motor down there, and it's not in the capacitor, so it's obviously in that huge motor you've got running in the center.
Well, this and the electronics will go with it.
Okay. Now, why hasn't the public seen something like this before?
Because most people only know, they think the only thing that exists is electron flow, and they don't know that there's lots of forms. Nikola Tesla said there's many forms of electromagnetic forces or electromagnetic flows, types of electromagnetism, if you want to say it that way.
Okay.
Almost everybody's only familiar with electron flow. Well, actually, most people are not even familiar with that. The only thing they teach in colleges, I'll put it that way, is electron flow. That's it. There's many other things. You need to know how to work with several of them to get them to work right.
Okay. So the trick is not only just being able to build it, it's knowing how to tune what you're building.
Right.
Okay. Is this a science that's readily known anywhere in the world, or is it something you guys have come up with?
Well, we've developed it, we've redeveloped it. Keeley was the original one in this country I know of. Stubblefield, Keeley, Tesla, those guys worked on this stuff. We've made an effort to duplicate their work. There wasn't much information left from them. Another one was Henry Moray. He did write a book or two that you can still find sometimes. It's hard to find, but you can get them. So there's little bits and pieces of information here and there. But a lot of building, a lot of money, a lot of time. We had 50 guys working for years. Well, a couple of them were women, but 50 people working for years to get where we are now.
So
It just happened. Didn't just walk around the block and there we are.
So your ministry didn't one day just open up and have these technologies available?
It took us about a year to get the first over Unity device working. Which that's available on video too. That's the old delay line mode. The
Okay.
first delay line mode. That was the first one. first clearly over unity device we ever did.
Do you think this is the most advanced motor system that you have available?
No, we can do solid state. It's basically a matter of who has the money and how much do they have and what do they want to spend it on and so on and so forth. It's basically a matter of cost. It's very cost effective on a large scale. Everybody for some reason prefers small scale stuff. If cities or countries or governments would go along with this, or the whole planet, we can literally build one device and run the whole planet.
You can build one device to run the whole planet.
All the electrical needs of the whole planet. We can transmit the electricity through the air. You don't need the wires, and through the earth itself as a conductor, and done deal, basically.
Now, let me ask you, with something like this, do you think it's providing the power, or is it a conduit for power that's already out there?
It's a conduit for power that's already out there. But modern quantum physics recognizes 200 million watts in every cubic foot of space, something like that. And so, some branches of physics say it's impossible, but other branches of physics say there's this extremely large amount of power available, even in empty space.
So this is a conduit. This is not a generator.
That's correct.
Okay.
You can call it a generator if you want, because all generators are conduits. It's just most of them do it very poorly. That's basically what's going on.
Well, we've been talking now for about 2 minutes, and the lights haven't dimmed, the motor hasn't stopped, and nothing's exploded. So obviously you've got a handle on
Yeah.
how to create this type of energy.
The good part is nothing exploded. Yeah. But even if these things go on you, the worst you get is a big noise. As far as pieces going flying like on fuel systems, you never get that. People are catching on fire and fire going, so you never get that. The worst you get is a loud bang on these types of systems.
Now it sounds like if you're a conduit for this much energy, it sounds like you'd be emitting a lot of type of radiation, some form of radiation.
No harmful radiation. Electromagnetic fields, that's it.
That's it. So, and this is the kind of field that's expanding out 25 feet in all directions, is it?
Well, I don't know if you want me to go into all that. You want me to go into all that?
No, I mean, no, you don't have to go into the science of it. I'm just trying to...
If you want to, the short answer is no, I guess. But to tell the whole truth, there's quite a bit to it. But the short answer is it's a very safe field, so on and so forth. It's safer than what normally comes out of the light bulbs. That's basically the short answer.
Okay, well, great. Well, I'm overwhelmed.
I should have brought the gloves.
Might be a little warm over there.
All of a sudden it's dark.
And it's still running.